Let's get started. Still more people might come in, but we can still start. So this is the today we're going to do the first video. And as I've I listened to these videos back when they came out in September, but I forgot how disorganized they really are. So I listened to this video, and then I realized that the other problem that that Srinivas pointed out is that the library has changed a bit, and some of the notebooks have changed around a bit. So what I could glean from this video is that he's looking at this. He's looking at this PETS 10 notebook. As you can see, almost everywhere in the video, he's looking at this PETS 10 notebook. So that's what that's the one we're going to use. That's the one we're going to go through today. And let me see. There we go. Get that out of the way. Let's see. If I switch between, you can see right now that I'm displaying the the page with all the walkthrough videos, right?
Yeah.
Okay, great. So if I switch tabs, can you see this? Welcome to FastAI version 2.
Yes.
Yeah. Okay, great. So this is the sort of the explanatory page for the FastAI version 2 library, and it tells you how to install it and so on. I found with a Windows machine, I really can't use it. I can install it, but it doesn't work for me. So I finally had to give up and go to Colab to do any of these, to do any of the notebooks. Okay, let's see, another tab here. This is a page that you should be aware of on the forum, where Jeremy lists all the videos, and there are notes that go with each video, or there's actually a page in the forum that has notes from various people have made for each video. So this is a good resource to use. If you listen to the video and you get stuck or you don't understand something, there's people that put explanatory notes in there. It's a good resource to refer to. Finally, let's see. So what I did was, well, let me do something else first. Dinesh asked, which version of the FastAI 2 library are we using? There's a dev version, and that's the one that they always refer to in the videos, that Jeremy always refers to in the videos, but that's sort of superseded by they've actually finished the development phase, and now they have the FastAI 2 library is here. So this is the place where we're going to refer to, and then all the notebooks that come from all the FastAI version 2 notebooks that he's going to be going through are in this NBs folder. So as you can see, there's the one we're going to look at today is the 10 tutorial PETS, and you can see that was updated 2 months ago. Some of these things are more recent. The library work has been more recent, but so this is essentially the final version of the FastAI version 2 library. Given that Sylvan has left, I don't know if they have anyone to take his place. I suspect that they won't be devoting a lot of effort to further development of the FastAI 2 library now that Sylvan's gone. So anyway, this is the place where all the notebooks come from that you should be aware of. It's this NBs directory inside of the FastAI 2 folder on their GitHub site. Okay, so what I did was I copied that notebook. Eventually, I suppose I'll copy them all. I made myself, so in Colab, in your Google Drive, if you use Colab, there's sort of a default folder where it looks for all the notebooks, and it's called Colab Notebooks. So in my drive, I made a subfolder called FastAI version 2 library, and then I copied in the notebook that we're going to be using today. I suppose eventually I'll copy in all the notebooks so that I can easily access them from this point. And then, okay, once I did this, I made a bookmark here so that I can get back here whenever I need to work on the FastAI version 2 library study group. Okay, and
so
then
Joseph,
yeah.
when you save, it will still stay in the same place. When you save the notebook, if you make some changes to the notebook.
Yeah, if I make some changes to this notebook, I'm working. Actually, what I do is I copy the notebook into here, into my folder, and then when I want to work on the notebook, I open it up. And so that's what I've done here. And it's pointing to that. So if I want to save it, I just save it, and it saves it right there.
Okay.
It knows, it knows where to find it. So it's a little bit of there's a little bit of a learning curve to figure out how to get around in Colab and not lose things and so on. So if you aren't familiar with this, post questions on the Slack channel, and I or others will answer them to get you started. So at any rate, I can, I haven't done anything to this notebook yet except put a few comments in it, but I can share it. But you don't really need me to share it because you can get to it from here. You can get to it from here. It's right here in the FastAI GitHub. So one thing you could do is you open up Colab, and then you can actually work directly on a file from GitHub. Let me see if maybe we can do that for a second, so that you could get started. Yeah.
The other tip, Joseph, is if you had the Colab set up for your part 1 of the course, you could just download the notebook into that and run this notebook from there as well. And as long as you don't run the last cell, which is exporting and thereby could cause problems. But as long as you don't do that, you should be fine just using that setup.
Yeah, I actually started from that point, but then I decided to make a separate folder for my work in this associated with this study group. So I just made a folder.
I did the same thing eventually, but I'm just saying in terms of setup and stuff, if you just want to get going, you could potentially do that as well. It's just the same setup as for part 1 of the course. Yeah, that's true.
Although I didn't have to do all the things. I mean, on part 1, you had to do a lot of things in the first notebook, and so this is a little bit. This might the fact that I could get this notebook to work so easily might depend on the fact that I already had most of the stuff installed from previous. But here's the first cell. You have to have this mount your Google Drive. I think you have to have this so that you can access your stuff. Yeah, you definitely have to have this so that you can access the thing on your own from your own directory, from your own Google Colab folder. Let's see. This cell I don't really need. If you do it for the first time, you have to install FastAI 2 if you haven't done that before. So I commented this out. And there may be, and then you have to do this too. There may be some more magic things you have to do before getting everything to work. So if you have any trouble getting this first PETS 10 notebook to work, post on Slack and people will help you to figure out what you need. There might be more stuff you need to do here than I did because my setup is already, I've already installed most of all the stuff that I need to run FastAI 2 in my Colab, in my Google Colab account. So yeah. What else I wanted to tell you? Okay, well this is the actual notebook this is the 10 tutorial PETS notebook on GitHub in that notebooks folder, remember? So here it is on GitHub, but I copied it into my folder, and this is it in my folder. Like I can actually directly work with it. Okay, yeah. So before we get started, what I want to do today is just go through as much of this as we can, and yeah, that's basically in what Jeremy did on the first video. Any questions before we get started? Okay. Okay, so going to the top, I did all this stuff, processing. Okay, so the first thing he does is he gets the MNIST data for the first couple of examples. So that's this one. He has this, FastAI 2 has this thing called UNTAR data, and there are internal data sets that FastAI 2 already has. Well, no, actually, he's actually getting this directly off the web somewhere. And so this is kind of like a magic code that gets you this data set. Then he gets, okay, so source is where all the data is, the data that you just downloaded. And then items is all the image files. He has this FastAI 2 code called get image files. And then file name, FN, is the first item. So we can do that. And it's just the first item is stored in, normally when the data that you import is by default taken into this .fastai/data folder, right? So when you do this import here, when you get this from the web, it actually saves it in this data folder. And so it made its own directory name mnist-tiny for that data set. And so there's a subfolder, there's a folder for the training data. There's a folder for training items that are labeled with that are the digit 3, right? Because training has subfolders for all the digits. And let's see. And then this image is called number 9059.png. So that tells us what file name we're working with. Okay. Right. I'm trying to, let's see. Yeah, that's good. All right, so okay, so I'm not sure what I'm doing here. I'm just trying to see what the type of source is. Source, it turns out to be its own type. It's a POSIX path, and that's why you can use this slash and append the name of a subfolder onto it. Let's see. And items is this thing. It's a fastcore.foundation.l, and I think Jeremy has more to say about this later. This is the capital L object is the FastAI 2 version of a generalized list. So it's like a list in Python, like a Python list. Lists have lots of properties that we don't often use, but the capital L type of is a special type of a list that has even more properties. So suppose we'll be learning about those later. Okay.
Sorry,
yeah.
Joseph. The first thing is it's pathlib, and it's a pathlib object. So in fact, last time I posted links on pathlib. Jeremy uses pathlibs all over the place, so it's good to get familiar with how they're used in Python and what all you can do with them. Okay,
I guess I didn't notice that link, but you posted it last time?
Yeah, there's a whole bunch of, I think they were on Pathlib that I posted.
Okay, great. That'll be good to get used to that. Let me just take a quick look at the chat to see if anyone has. Okay, so let's see. Somebody said, let's see. Let's see, questions from, yeah, Anand says he has a lot of issues with Windows, yeah. I heard that that they're gonna make WSL, I think WSL is the interface to Linux from Windows, and they're gonna make some improvements on it so that, I mean, right now it's almost useless for machine learning because you can't use your GPU. If you have a nice machine and you use this WSL to get to Linux, you cannot access your GPUs, but apparently they're going to, within the next few months, be releasing a new version of WSL, the Linux interface that does allow you to use your GPU. So that might be a game changer. We'll see. Let's see. Ellie Whitman says, I ended up using a remote notebook server on a Linux machine, so I just launched the notebook server there, and then I access everything from my Windows laptop. Okay, so you have access to a remote Linux machine. Yep. Yeah, at work, a lot of people at work have Linux machines that they can get to, and that's one solution, yeah. Let's see now. Someone, Sriram Jaju says, do I need to be aware of the FastAI course to go through this walkthrough? I haven't gone through the 2019 course. Well, I would say you probably should be familiar with some form of FastAI. You may not have gone through the 2019 course, but maybe you went through the 2017 or the 2018 course. You probably do need to have some familiarity with the FastAI course. It's probably a steep learning curve otherwise. Let's see. Ellie Whitman says any version of the FastAI courses comes in handy, but you probably need to look up some more stuff and take some more time if you haven't done the course. Yeah, I would say it's possible maybe, but it's a steep learning curve to get used to all the FastAI jargon and everything, and new and actually new library functions and so on. Let's see. Srinivas says, yeah, okay, that's good. Anand. Oh, okay. Anand posted this thing, why you should be using Pathlib. That's probably a useful link. Anand, if you don't mind posting that on the Slack as well, so that it will survive after this meeting. Oh, and Srinivas already posted that. Okay, so that's, yeah, it wouldn't hurt to post it again so we could, because the thing I don't like about Slack is that the history gets lost. There's too much to scroll back up through, and then at some point you can't even get back farther unless you pay. You can't get back. So some messages are going to be lost in the annals of time because Slack wants you to pay for a paying version that you can. Anyway, that's the one thing I don't like about Slack. What's the difference between POSIX Lib and Pathlib and POSIX Path? I guess Srinivas, could you answer that?
Yeah, it's the same. That's why I said it's just, if you use, he uses pathlib, and pathlib.posix path is what the path objects turn out to be. So, and it's not just the one link on pathlib. If I recall, there were maybe the Python's documentation on pathlib as well. And I posted a PDF, so the links should be there. If you can download the PDF from Slack, you'll have the links. And I have the update for walkthrough part 2 that I'll post at the end of this lecture as well.
Oh, great. Okay, sounds good. Okay, someone, Alex posted the information about the WSL2, the new version of, I forget what WSL, it's something about Windows, and S something, I don't know what S means, and L means Linux. So it's basically a Windows interface to Linux. Yeah. Okay, thanks everyone for the comments. Okay, so just now to go through some of the things in this notebook. So he uses the Pillow image library, and so that's what this PIL image is. It's a image from the Pillow. It's using the Pillow library to interface with images. So the first thing he does is he uses pilimage.create from the file name, and then we can look at the image. We can look at the type of it. It's a, let's see, why did, let me get rid of this and see it. I just wanted to see what it was, but what prints up when you say image? Oh, okay, so he actually prints up this image of the 3, that's what it does. And then if I want to see the type of the image, let's see. Oh, why didn't it? Oh, okay, this is what I'm going to do. One thing I don't like about Jeremy's way of coding is that he likes to compress as much as possible on one line. So I like to see every command have an individual line to itself. That just, for me, that's just the way I like to look at it. Anyway, we can see what the type is. It's a PIL image, and print the image is just a little postage stamp sized 3. Now the first thing, I think PyTorch uses, when it looks at an image, the representation of image, remember an image is basically 3 frames RGB, and each frame in this case is going to be 128 by 128. So and PyTorch has a default way that it likes to look at these images. It instead of it wants to look, if it's going to look at an RGB image, then the channels come first in the specification. So so he has this thing called tconv to tensor, and I think it takes the it takes, let's see, what I should ask for is image before I do this. Insert code cell. Let's just see what image I don't know if it has a shape the way it is. Let's see. Yeah, so it's 28 by 28. And now, so it's only a grayscale image. So to convert it to something that can go into PyTorch, it has to have channels. So I guess this 2 tensor converts it by just copying it 3 times. Instead of an RGB channel, you don't have RGB, so you just make 3 separate copies of the grayscale image. So that's what this 2 tensor is doing. It's taking as an input the image, the pill image, and then converting it to a tensor. So now when we look at the shape, we will see.
So quick question here. This has always kind of thrown me for a loop. Why don't we just use two tensor of image directly? Why do we have to name it to a different tcon and then use it?
It's just a convention he uses to use the function to tensor, and in fact, I believe in, you can confirm that, Joseph, by running type of tcon after he converts it. You'll see in subsequent, deeper in this lecture or in the next lecture, he'll show you why he always converts things, or not always, more often than not, he converts stuff to a function and then calls that function on the input that he's passing, which is what he's doing here.
Yeah, I've seen that too. But I understand your question is you could have just used this class directly to apply it to the image, right?
Yeah.
That's what your question is, right?
Yeah.
Yeah. So the answer is I don't know why he does this, but Srinivas says he does it all the time. So let's just bear with it, see what goes on here.
And it's convenient to stick with that when you have, as he will do subsequently, for splitters, getters, and stuff, to stick with the convention of creating a function that returns a function with then you provide the input to. So by sticking with the same way of doing it, he doesn't have to switch then when he does that to calling it differently. So he just does it the same way right from the beginning. So we'll see that later.
Okay, let's look at this 2 tensor function just so that we get an idea of what it looks like. Because that's a class, actually.
Not the call, just 2 tensor question without
just like that. Okay. So this is a class, and let's see. So it's very 2 tensor x. So it takes an input of x and also a dictionary of arguments. I'm not sure what those are. What those would be.
He and he inherits from transform. So he's just converting it to the. He's just converting. So in fact, Raquel, who is online as well, went through it. 2 tensor is actually a PyTorch function. He's converting that function to a transform in FastAI by doing just the call to tensor and inheriting it from transform. So he's making that function into a transform.
So 2 tensor is a PyTorch function then?
Yes.
I didn't understand that. Okay.
Converts it to a transform, so he can do a little more with it. Okay. And we'll see that later.
So that sounds like other way around, Srinivas. Like the definition of a class 2 tensor tells me that we are creating the fast.ai 2 tensor class and inheriting from a transform.
Yes. But the function of 2 tensor comes from the PyTorch 2 tensor. And that's where it's also, if you see, its type is transform meta. So we'll get into all this a lot more later. But right now, it's just a transform is what you need to understand. It's a FastAI transform currently, but its functionality is there defined in a PyTorch function. And you can convert functions to transforms, and we'll get into that just a little bit down the road.
Yeah, so 2 tensor, if it's in Python, if it's in PyTorch, it has its own meaning, but now in FastAI 2 library, when we see 2 tensor, that means it's already been mutated into this new object that inherits from transform. So it doesn't behave exactly like the 2 tensor in PyTorch.
Yeah.
Because it's inherited from transform.
And what the order means is something we'll get into later as well.
Okay. Yeah, you can go down lots of rabbit holes on every single cell here if we just if you ask yourself questions about things. Yeah. So so anyway, as Srinivas said, we'll just be content with this notation from now, where he just defines this thing as its own function here and then proceeds with it. Let's see, creating labels. Okay, so now again he has this notation. Anyway, so it has this function that extracts a label from a file name, and we can look at that how it works, but let's just trust it as a black box right now. And so it looks at the file name and knows, because we've already seen the file name has in it the clue as to which is the label. Where was it? Anyway, we saw that it was in a directory, a subdirectory called 3 right here. So presumably it's this this function looks at the file name and says, oh, this is the label, and then it extracts that as the label. So
in lecture 2, he gets into the code for a lot of getters, splitters, and stuff. So we'll see those details, and we should skip over it.
So for now, we can trust it as a black box, and we understand that it does have the information from the file name to extract the label. So as I just showed you. So what it does, it extracts the label, converts that, and that label is not the integer 3, but it's the string 3. So then he has this other function, categorize, that takes a vocabulary of labels, and then he says, let's call this label, let's now make label into tcat of label. And so now it's an object called tensor category 0, and tensor category will have we'll have 2 categories, 3 and 7. So if I said, well, yeah, so that's what it means by tensor category 0. It's the first label. So now the label isn't the string 3 anymore. It's this tensor category thing. And then we can decode the label if we want to get it back. If we want the string label back, we have this decode function, because categorize, this class, has a decode class that allows you to go back and forth between the decode class goes backwards between the tensor category and the original label. So if we ask for the original label, we get it back. Now he says there's a way to compose the steps there's a pipeline class in FastAI 2 that allows you to compose several steps. And we saw that we created an image, we converted it into a tensor. So now we'll combine those into a pipeline. And now the image has the right shape that we wanted, the 3 channels, the 28, I think it's height, and the 28 for widths. So this is C for channels, H for height, and W for width. That's the PyTorch. That's what PyTorch expects the images to look like. Let's see. So now he has a show method to show the image. I think every let's see, every pipeline object or these kind of images have their own. Sorry,
the transforms and have encode, decode. Then within the pipe, you can say show, and it'll go through the transforms and see which one has a show. And we'll get into that in much more detail as well. So I just defer. It's just that the show will go through each of the transforms it provided, and we'll figure out which one has the show. And again, we'll get into that in much more detail in the next lecture.
Right. Okay. So as Srinivas says, the 3 things we should be aware of right now are the encode method, the decode method, and the show method so far.
Yeah. Can I ask you a question with regard to the pipelines? Can you go up a bit? So there are just a little bit up.
Yeah, right there.
No, up. On the pipeline, when we are creating the pipeline. So here. So what we are doing is the pipeline is the function we are calling and saying we have this list of two operations?
List
Yes.
of two transforms.
Yeah.
So PIL image create is a transform, T-convert is a transform. As you saw, it's actually calling to tensor. And each of those functions we'll see later, if provided as a list or list of lists, because you can do multiple lists to pipeline, will get automatic. In this case, they are already transforms, but even if they're just functions, will get converted to transforms automatically by the pipeline class code. And again, as all of this, we'll go through pipeline class code in much more detail later. And then each of those transforms is applied to the input that you provide to pipe, which is what is happening when, excuse me, in the second line of the code that Joseph has up with, when you say image equal to pipe of file name, that means that file name is converted by the first transform, PIL image create, to create a PIL image, then converted to a tensor by the transform T-convert, and then that is stored in IMG, and therefore when you do img.shape, you get 32828.
Yeah. Oh, great explanation, Srinivas. Yeah, so this is a list of transforms then that gets, so the input to pipeline, so pipeline is a class in FastAI 2, and it takes an input that's a list of functions, as Srinivas said, but the functions, if they're not already transforms, they get made into transforms, and then they get composed, they get applied in a serial fashion to the input. So you first apply you first create this this image, and then on that image then that image becomes the input to this tconv, and then so then it creates a tensor out of it. And finally, the output is this tensor that you've created.
And just not only the existing function in a library, but you can create your own function and list in this pipeline list.
Yes,
yes.
You'll see that.
Yeah, there's an example coming up.
As we go through pets, you'll see that happening. So just hold your thought. Yes.
All right. Okay.
Short answer, yes.
Yeah. In the original video, he tries to do too much. I think he goes into this what is it, this advanced application of creating your own series of transforms. And I think I noticed he split that off in the library as its own. Let's see, if we go to the documentation, let's see. Okay, this is FastAI 2 tutorials. And if you go to the advanced tutorial, he does this Siamese network thing, and he splits it off into this advanced example. He tried to do this in the first video, so I don't. So and you know,
it's covered much better in the second video, Joseph.
Yeah,
so if you just
yes.
Second video gets into that.
Right. So I didn't pay attention to that. It's actually in the original notebook that he's covering in that first video. I think is notebook 8 or something.
Yeah, it just named differently, as I mentioned.
Yeah.
That's why I provided, you know, here's the stuff you need to pay attention to. And I have the same thing for video 2 as well that I'll post at the end.
Great. Yeah, that's great. So I just had to go through the video and figure it out for myself that, yeah, it's not really going through this notebook 8. And that notebook 8 is in any case from the dev library. And we really want to look at the notebook 10.
Yeah, so anybody going through, if you use my PDFs as a guide, that will help you kind of skip through stuff that you may not need to pay attention to at this level, that the level we are at in each video, and also points out what's changed and what's different and which notebooks you need to go to work through those.
That's very useful. So you won't break your head when you get into, because like if you try to go through and look at a Siamese tutorial, it's just, at least for me, no, I'm not going to do it. So I'm just going to go through most of what he has in 10. I'm not sure we'll get through that in this notebook 10. I'm not sure we'll get through that today, but at least you'll get a start and get a flavor for how to go through this notebook on your own. And you know, whatever I don't finish today, you can finish yourself. The method I'm using is I just go through and I try to understand each cell, and if I don't understand it, I'm really obsessive, so I tend to just go go down the rabbit hole and figure out what's going on. I think if someone were more practical than me, they would say, okay, well, I'm just going to accept that there's a black box and move on. But it's hard for me to do that. Anyway, Yeah, so we've gone through this. Now he says how to, this is Dinesh's question, creating your own transform, and he shows how to do that now. He uses this thing called the albumentations library that's external to FastAI, but apparently it's just a whole bunch of, it's just a whole assortment of different transforms that you might want to apply to your images, like, you know, shifting and cropping and rotating and flipping and all kinds of stuff like that. The stuff he went through in the FastAI 1 course. So you have to install this. I don't have to do it because I've already done it, so I commented it out. Now he's going to get the pets database, which is, remember, it's a bunch of, I think it's a bunch of cats and dogs, or maybe it's just dogs. So it's the same format as before. You get the data set. You use that, what do you call that, pathlib to specify where you want to get the files from. The pathlib, I guess what's nice about pathlib is you can just, if this is a source is a pathlib object, and if you have a pathlib object, you can just create a new path by, you know, by appending the subfolder onto the end of it, and then ask for the items from that. Okay, so now we do that. We find out that there are, you know, 7,400 items in there. We open the first one with image create. And it's this nice dog. If we wanted a different dog, we could always specify a different one. Or no, it's a cat. Okay, so this one's a cat. Okay, but so let me just continue with this cat because it's kind of nice. Okay, so he wants this shift, scale, rotate transform. What is that doing? Remember, it's shifting the image one direction or the other. It's scaling the image by blowing it up or by magnifying or demagnifying, and it's rotating it. So it's doing three things. And so for this demonstration, he's just going to import that one from the albumentations library. Now he defines this new function called aug, which is shift, scale, rotate, p equals 1. This p means probability of applying it, because, you know, when you do the image augmentation, you can actually specify that you don't do anything at all with some probability. So if p equals 1, that means we certainly apply the transform. If p equals 0.5, that means half the time it would apply the transform, the other half the times it would do nothing to the image. So that's what that p means. So now he defines a new function. You have to get the, you convert it back to NumPy first, because albumentations, these functions need NumPy inputs rather than tensor inputs. So he converts it. Then let's see, aug image equals, the augmented image equals the augmentation applied to the NumPy image operating on, oh, and I'm not sure what this is, let's see. So these things must have these. I'm not sure what this is. It's perhaps that the input thing has an image part and a label part, and it's just looking at the image part. I'm not sure. So it creates, I think that's what it is actually.
Yeah.
So
could you check what's the type of AUG when we created shift, scale, rotate?
Yeah, good idea. Okay, let's see. Type AUG, print. It's going to be an albumentations object, an augmentations.transform.scale rotate. So this is from the albumentations library. It's a special kind of object. Let's see if we.
I think if we see what
is
returned by shift, scale, rotate, that will give us an idea.
It seems to
although
be a directory, which is why you index into it using images the way I thought about it, but I didn't get into the details of why he indexes or uses that image part to get into the image.
Yeah, I'm thinking that each one of these objects has the image part and the label part, and you only want to operate on the image part, but I could be wrong. Let's see. So you start with okay. So what we could do now is, let's see, we could ask for something, get some information about og. Oh. Well, so he's doing two things here. So we could just go og image. We could just ask for this part, og image 0. This is, and then I could just say, well, I guess what I did is I tried to break it apart into two pieces so that we can see, and maybe now we can see what this thing is. So og image, so og of image. So what is produced by that? And we can now ask for. This is what I mean by going down rabbit holes. I mean, it's good, but you can find out stuff this way. So. And now I'm going to ask what this object looks like, and then we can see that, what this image, maybe we can see what pieces it has. Anyway, so let's do this. And then if I do this, then it will actually give me that information. In doing it, it will print out this. It will print out this command, I think. So let's see if it does that. I might have to put a print statement in front of there. So it gives me the cat. But it didn't give me this. So maybe that's because I didn't do this first. Let's see. No. So I need to actually do this, print. So now I'm going to get to see what that object looks like. It printed it on a line. I would have rather it printed it in a column. Let's see. Clear copy from keys get items. This doesn't help.
Yeah, you need to go to the argumentation library, as somebody said, and figure out what it is returning. And my guess was that it's returning a directory which you're trying to access the item attribute of. Or
yeah,
the item key of, I should say.
Yeah, a dictionary or something.
But that's a rabbit hole I chose not to go into.
Yeah, and it's good for us to skip that one too, but you can do it. I mean, the point is, if you're curious and you want to find out stuff, you can do it. It's just how much time you want to spend doing it. So let's go on. So let's see. So we built this thing called og transform. When we give it an image, it then comes out with, and now I can cover, let me undo all the stuff that I did and restore it to the way it was. Let's see, NP image. I don't need this anymore. And I don't need that. And I don't need that. So restoring it to the way it was. Now I get that. Get rid of this. And now it just gives me back the cat. All right, fine. Okay, so now it creates this transform object by making this thing into a transform. And transforms have all these special properties like encode and decode and show and all that stuff. And I presume that's why he's doing that. So then he even goes further and creates a subclass called argumentations transform. And just for my own good, I do this because I don't like to look at many commands on one line. So now he's implementing sort of the same thing This is really the same thing he did before in AUG_TFM, but now he's implementing it in a class. Okay, so.
Important thing to note, though, because that's critical as we go forward, and he calls out in the notes, is he's casting the output to a PIL image by using a PIL image.create around the org image, the last line of the code.
Yeah,
so
and
that
also
returns the PIL image. So it'll make sure that the output of the transform is of type PIL image.
yeah, is that what that's what this line does, right? It says, oh no, this makes sure that the input is a PIL image, right?
Right, correct.
So this is a new thing that it's a new feature of Python. It allows you to force input types to be a certain thing, so that if the input type isn't that certain thing, if the image as an input isn't a PIL image object, then it won't do anything. So that's
No, Joseph, in Python itself, it's just a type annotation. So you have to install something else that will check whether the type annotation is correct or not and complain. So Python itself doesn't do anything. It just annotates it with the type. You have to have an external checker of some kind to, so it doesn't enforce anything. In FastAI, he uses, and we'll get into this in much more detail, as I said in my orientation, this thing where he uses the type dispatch to check the types going in and out and do what you just said, which is operate, for example, the encodes or the decode function only on certain types. But that's a FastAI specific thing that it depends on the type to do or not do certain things. Python itself, type annotation annotates the type, but by itself it will not, because Python is not a type language, it still isn't even after the change. It's just that you have to, I forget the tool that most people use, and you can use that to then complain, which will then complain if the types are not what they are annotated with, but that's not checked.
Okay, so this new feature of Python allows you to enforce the types on the input and output objects, but it doesn't enforce them. But it opens the way for you to write your own code to enforce them. That's what you're saying?
Correct. And externally, you'll have to import some other tool. Now, in FastAI, the type of inputs and outputs is used by FastAI library itself to check and dispatch different portions of the code depending on the type. And that's something we'll get into in much more detail of how FastAI does that and what changes to Python he makes in order to achieve that goal.
Okay, got it. So, so he calls this a type annotation, and the idea is eventually to enforce that, so that then what I said is wrong, and what Srinivas said is what I should have said, which is that in FastAI 2 he enforces the type, and if the input image isn't of the correct type, then the function doesn't do anything. That's so he's basically morphing this language into something that he wants it to be, that he wishes it were. That's what FastAI 2 library is all about. It's about making Python and PyTorch, molding it into the language that Jeremy thinks it should be. So anyway, so now we built this new class, and now we can apply it the same way we did before. As an input, remember that it inherits from transform. So that means that you can give it an input that is a transform. And it will know what to do with it. So, you know what? It's going to give it a label of a dog. We don't want that. So we want, I shouldn't have changed the
No,
I
the
shouldn't have
image
fooled
change.
around with this thing.
In this case, the image change, so you just have to
Yeah.
manually edit it
Let me
to
just
catch.
go back. Yeah, I don't want to have to do that. So I'm just going to go back and get the dog, continue with the dog, since he's already done the work.
But the other thing to note, Joseph, is, and this is the fact of what you just said happening in that illustration. If you just pause, yeah, if you continue,
Yeah.
right when you execute that code, we can see an illustration of what you just mentioned. See, the transform is actually sending two inputs, the image and the string dog.
Yeah.
But the transform transforms the image, it rotates, shifts, scales, but does nothing to dog.
Yeah, and then the show image function, it knows to take the title string, and so you can give it the title string, which is already here as B, as dog. So the title string is specified as dog, and it automatically then the show method then gives you the image and puts the identifier string in the header, in the heading. And I just want to show you. This is, let's see. This is the image. This is a transformed image. This is the original image of the dog, right? And the transform has rotated it, scaled it, and shifted it. So it doesn't look like it shifted it by very much, but it did. But it certainly rotated it, right? Let's see. And this is some kind of an artifact here. This doesn't look good. So here's the original image, and here's the dog's left paw. The dog's left paw looks okay, but something funny happened over here. This is an artifact. This thing here is an artifact of the rotation process. And then we also see some of the dog's fur over here. So that's another artifact. Anyway, that's interesting to notice. Yeah, so there's the transformed image with its new label. So now he switches gears and he says, okay, now let's look at this CamVid data set, which is basically scenes of streets and so on, vehicles, pedestrians, bicyclists, cars. And he's doing some kind of an object detection process here with this data set. So he's got this CamVid tiny. So there's a famous CamVid data set, and he's got a smaller version of it. There is a smaller version of it available online, so he imports that with the same kind of a command we've seen before with this pathlib kind of thing. We see that there are 100 images, 100 items in this little database. We look at the first item, and if you just looked at the image, let's see, I could do this. If you just look at the image, you'll see that this is an actual, just a photograph, like that. But he superimposes over it the mask that was created, because I guess this database has both the images and the masks. So the mask is the labeled, basically the labeled data set, which it identifies, all the different pieces. This is probably called street. This is called pedestrian. I don't know. It might have fire hydrants or whatever. Anyway, so this is the labeled, basically the labeled data set. Let's look at this command here, where he creates the mask. So there's an image. So he has to create the image from the image item, and then he also creates a mask. And let's see how he does that. So CV source is this pathlib object. CV source labels. So that's where he looks in that directory. And let's see, CV source labels. And now this is a string. This is an F string, which has in it CV items 0.stem. So this is the image. This is the actual image that we saw, same one as here. .stem. I'm not sure that has a. I'm not sure what the stem property is. And then so he's building a file name, I think. Let's see.
Yeah, the masks are typically, if I recall, from the CamVid stuff, the masks are stored in the root, by root I mean actually the better word is stem, which is without the extensions of the items, and then attached to it underscore p, and then the suffix of the items. That's how the masks for those images are stored in the labels directly. So he accesses the mask that way.
Okay, so he gets the he accesses. So this is mask create. So he's creating a mask, and he's telling it where to go to get the information that he needs to create the mask. That's sort of the black box version.
Yeah.
And so now so this first command shows the image, and if I, like I said, if I comment out that, you'll get to see the image. But now he's superimposing the mask on top. So I'm not sure what CTX means, but
that's context, comes from Matplotlib.
Okay.
Details of using the same context for the mask as you do for the image, so that they align exactly on top of each other.
Oh, okay, great. But what if I just showed the mask itself? We can do that too, I think. Let's see. Why didn't it do that? Oh, because I didn't. I'm not sure why it didn't. I'm not sure why it didn't show the mask all by itself. Anyway, another rabbit hole to go down. But let's move on a little bit. So now he says we write a class of item transform that can wrap any albumentation's augmentation transform. Remember, that's like the shift, scale, rotate, but only for a segmentation problem. That's the word I should have talked about. This is a segmentation problem when you take an image and you segment it into different classes, right? So this is like street, this is pedestrian, and you show the classes by colors, by different colors. So this is like a label. This is kind of like a labeled image, and it's labeled with all the, you've basically classified you classify in a segmentation problem, you classify every pixel of the image into one or another of the available classes, right? So these pixels, the blue pixels are pedestrian class, and I don't know, this is a building class maybe. This is a road class. This is a sidewalk class, right? The different colors mean different things. All right, so now he says, special version of, he's writing a special subclass of item transform that can wrap an albumentations transform especially for a segmentation problem. So my question here, I just ask myself, how is an item transform different than a transform? Because he's mentioned what a transform is, but he's never mentioned an item transform yet. Yeah.
And we'll get into a lot more detail, but the short version is it acts on an item, and the transforms typically, as you'll see, acts on tuples. So that's my understanding, but we'll get into a lot more details. You can do different things with transforms as we go through and focus on transforms in detail in subsequent lectures.
Okay, so the thing to keep in mind is what Srinivas says is that this will take just one item, or in other words, instead of a tuple of inputs, it just takes
except I think he'll very soon point out that you can make a transform and have it only act on items anyway. So just think of it right now as inheriting, and it's a special type. It's a subclass of transforms.
Okay, so then let's look at what it does. It again, just for my own good. So it's taking this function aug as an input, and then it's making it into a method, right? And now it's got an encodes method inside it, and the encodes method takes as an input a tuple. So and the first part of it is the image, and the second part of it is the mask. So these are the two objects we saw up here, the image and the mask. And then I was asking myself,
and that's exactly, it's a very good question you asked yourself, because that's exactly where the item transform works. It acts on each item that you provide. So that's why it acts on both of the elements that you're providing it.
Okay.
You see what I'm saying? It acts on the image, it acts on the mask.
Okay.
That's why it's an item transform, because it acts on each item of what you provide to the transform. That's why it's an item transform.
Okay, so aug, this aug function that we've made, already it's very tricky. It already knows that it's going to get 2 inputs, or it already knows that it can have 2 inputs. Otherwise, this line wouldn't make any sense.
The org that actually it's more appropriate to say that the item transform, which he creates by actually the segmentation argumentation transform that he creates, which is of type item transform because it inherits from item transform. And so org is now an instance of this segmentation argumentation transform, which acts on each of the items. Therefore, that line works.
But org itself, if we look at org, and ask what this thing is, I think there is some clue that it implicitly can take 2 inputs, because it has targets, image, mask. It can take both of those kinds of inputs.
Yeah, so and it makes that an item transform to make sure that that works.
Right. So, but the function itself was already constructed and in argumentation. Remember, it's coming from this argumentations transform. So, org already knows what to do if you give it an image and a mask input.
You're right.
Yeah. So, okay. And so then it returns both the image that it created and the mask that it created in this pill image format. Okay. So now let's see how it works. And again, we're going to do shift scale rotate with a probability of 1. And oh, why didn't it do that? Let's see. That's the original. Let me make sure that I executed everything. I do this. I do this. Oh, there we go. Maybe it was just the rotation was close to 0, so you didn't. It looked like it didn't rotate at all. But now we can see that it did rotate slightly in the counterclockwise direction. Yeah, it looks kind of ratty though. I mean, here's the 2 lines. These were no, they already look ratty. Okay. Okay, I get it. So it did this. It did this shift scale rotate transformation to the mask and the image. Okay, then he says, okay, then he talks about decodes methods. Let's see. Now he's going back to the PETS data set. Get the files. Again, this is the conversion, resizing. And here you can see what's going on here. He has this permute. Okay, so he's doing a couple things here. First thing he's doing is he's converting the image. Remember, the images are, if you look at the, we could go down a rabbit hole here and look at the actual image tensor and see what it has in it. They're integers between 0 and 255. That's the standard format for an image. So now what he's doing is the first thing he's doing is converting them to a float and then dividing them by 255 to normalize them. Right, so that now the maximum will, so now the pixels will be, the pixel values will be real numbers between 0 and 1. That's what the result of this dot float divided by 255 does. But before he even does that, he does this, permute 201. So what does that mean? Well, he's actually reshaping the image from its input format, which is height, width, and channels, to the standard PyTorch input. Remember, PyTorch expects channels, height, and width. So permute 201 is simply shift, sort of taking C and stuffing it in here. So you're permuting 2, 0, and 1. In other words, 0 gets mapped to 2, 1 gets mapped to 0, and 2 gets mapped to 1. That's basically So this is the format it comes with, but now he's putting the second element, the two element, which is C, comes first. The 0 element, which is H, comes second, and the H element, well, let me go back. So 201 means take 2 and put it in the first and put it in front. So that means that C comes in front. 0 means take H and make it the second element. And then 1 means take W and make it the third element. So we've converted HWC, which is 28 by 28 by 3, to 3 by 28 by 28. That's what this permute thing is doing.
I got a little lost. Where is HWC coming from? I mean, where are we loading that?
I'm sorry, this is an abbreviation. I should just say height.
Oh, no, I get that. Height, width, and channel. But where did that happen? Because I thought we were always dealing with CHW.
Yeah, let's see, where did that happen?
That's because of image. Image that you get is, the image is of type.
It comes in as a string, as a flattened image, right?
Yes, and then he converts it, he opens it as an image from the file name.
So is that PIL below?
No, that's just
Okay.
an image.image or basic image, which comes in the HWC format that he needs to convert. And then it converts it to RGB, therefore makes it 3 channels.
Sure.
And then resizes it to size. So makes it square.
Okay. So the image.open is what brings in the
the
height.
image is where it comes in as as
HWC.
Yeah, and the H and W are 28 by 28, but now he's resizing it, so when it comes out, it's going to be the tensor is going to be 3 by 128 by 128. So it's basically scaling.
With, the pet images, Joseph. So it'll be whatever the pet images.
They're already okay. So they're already 128.
So then, if we were to open it with Pillow, would it have remained as CHW?
Good question. I think it depends on what PL image is. If PL image is that way, which I haven't checked, yes, then the answer is yes.
Yeah, I think it is, because previously up in the notebook we do use PIL and we don't do this permute thing. So I was wondering why he used image.open instead of just using PIL.
Yeah.
To avoid.
Yeah, and also, by the way, PIL, because it inherits from PIL base, is already a tensor. Here is converting it to a tensor, by the way. So that's why when you see the return, you see him cast it to tensor.
Right.
And the image then is not a tensor, as Joseph said. That's why the images, I think uint 8, if I'm not mistaken, for each of the pixel values.
Yeah.
That's
why.
Unsigned so he wants to show how you take it from a raw image of uints, which aren't even tensors, to get it to the format you want it to be.
Okay.
Because if you otherwise start always from PL image, then you'll assume that all images start that way, which is not the case. So he wants to show you an example of starting from an image which is not in that format. Also, the pixels are uints, and its shape is HWC.
Yeah.
Okay, does that make sense?
Yeah, this is where it gets super precarious for me. Like once if you are using like CV, OpenCV, I think there is a different order there.
So you have to learn the order that you need. But anyway, again, another rabbit hole. You can try, you can play with this and see what the actual raw images look like and compare them to the PIL images and so on, and find out for yourself what you need to know. Okay, so then he has this titled image, which, let's see, I'm not sure what the CTX, but Srinivas said it means context.
Context. He gets into it a little bit, I forget in the second. It's more a thing you use for matplotlib to make sure when you're plotting multiple things that you carry the axis, so it gives you the right subset of how to divide up your image space. So you have to dive into matplotlib to really understand what context is. It's related to the AX typically, and AX again is just a name you use, but it has to do with matplotlib details of how to display.
Okay, right. So I guess what you're seeing is that when you go through this thing, you have to figure out how to not get lost. Okay, you have to sort of balance your curiosity to find out what's actually going on with your desire to see the whole picture, right? And that's difficult to do. So what I do is I'll make this little comment for myself. I don't understand this right now, but I'll come back to it later. You know, so that if I come back through here, I can say, okay, now it's time to look up what this means. But right now, we'll just accept it. So he's creating this new class title image. It takes out as an input a tuple, and let's see.
The key thing there is the fact that he adds a show method to title image. And that's important, as we'll see, because, and again, I'm jumping a little bit, but just to give you the context, that whenever you use show, as he does in the next cell, then on a transform, when you use show on a transform, as he does, then any transform that has a show method will end up showing displaying as he does in the next cell. And we'll get into that in more detail in just several cells down the road.
Okay, so first he takes the first image and applies this function resized image, which we already saw here, to create this normalized image. You know, the pixel values are now between 0 and 1. It's in the right order. So and now we can just apply this title image function to it. And apparently all it needs is this test title, the show method. All it needs is this title. You can put anything you want here, and it will put that in the title. Okay, now he shows how to use the decode. So he has this pet transform that he defines this class called pet transform that inherits from the transform class. And it gets inputs of, okay, there's a tuple of inputs, vocab, and that, remember, is the set of all possible labels. O2I is a method to convert the label to its actual, to convert, let's see, the label to its index in vocabulary, I think.
Yeah, so the term he uses, I like, it's just a reverse dictionary.
Yeah, okay. So this is just a list. Vocabulary is a list of all the possible labels. And you can see it's a generalized list L with 37 items. And we could actually print them out if we want. And this is a dictionary that allows you to convert. So what's in this L is things like Abyssinian, Bengal. It's all the different types of dogs and cats, right? And each item has an index, so that if you understand this vocabulary, you understand that when somebody says a label of 1, they mean a Bengal cat. Or if they say a label of 3, they mean a Bombay cat, right? So that's the vocabulary. And then LBR is a labeler function, which I'm not quite sure of yet. So it takes as an input the label, the actual object, which is the text string, and then makes it into a label. And then he's got this decode function, returning the image and the vocabulary. Let's see, X. So X is going to have the image with it, and it's also going to have two pieces. The first piece is the image, and the second piece is the label. So that's what he's doing here. X of 1 is the label, and so this is the vocabulary corresponding to the label. See, vocabulary is a list.
The index into the list. X1 is an index into the
index into the list. Yeah, okay, right. X is going to be an integer, and X of 1 is going to be, sorry, not X. x of 1 is going to be an integer, and that integer is the index into vocabulary. So if x of 1 was 1, then we would see, well, we can print out the vocabulary. Let's have a look at it. Let me execute this. So vocabulary apparently exists already, so I can look at it. Insert code cell. And we're just going to see a list of all the different dogs and cats. And there it is. And there's 37 of them. It's not showing us all of them, but it's showing us that there's 37 of them. So if I do something, for example, like...
Can I ask a question here?
Sure, yeah,
so looking at the encodes and decodes function in this class, and looking at the O and X, I'm like, we are doing X of 0 and X of 1. So is there any way when we are writing the class, we would know what the X is going to be? I'm like, at this stage, it's saying, okay, you're going to have some X where we can extract the value of a 0 and a 1. Is this a list or a dictionary or an image? Is there any way in this class, looking at this class, we would be able to figure out what these type of these objects are?
I think I understand your question. It's a good question. So, let's see, tuple with, so title image.
I think
yes.
It's just the output of the encodes function.
The output of the encodes function.
Yeah, his question though is different, which is he's saying, do we know any way of how or what the type of O or X that you provide is? The typical thing there that I would say, Dinesh, if it's you asking, is the you would have to know, first of all, you would have to know. Secondly, where you can know from is what you're initializing the class with, because that's essentially what you are sending in. So if you provide, so in short, you would have to know what O and X are that you're providing to any method in a class, right? Because any method in a class that you're using or defining, you'd need to know what the type of data that method would operate on.
Okay, I get it. I'm like, that's the normal way, but
right.
Here, I know, like you understand what I'm asking, but
yeah, so that's why it isn't easy to say. Yeah. You would have to a priori know what the type of O is or the type of X is.
But I think we should listen to what Ellie said, because I think that's important too. I mean, so the encodes knows that it's going to return this image and a label, right? And so the decodes knows that it's going to take that as an input. So I think that it knows automatically. Decode methods have to expect that their input is the output of the encodes method. So I think that's the way, I think as Ellie said, that's the way it knows what the input looks like, what the input to decodes look like. The input to decodes looks exactly like the output from encodes, which is an image and a label. Okay, does that make sense?
Mm-hmm. Yeah.
Okay, so yeah, so thanks Ellie for that. That was good insight. So I wanted to show you this list. This is the vocabulary list, and if we ask for the index vocabulary at the index of 3, then we know what it's going to be. It's going to be the Bombay cat, right? So that's how we make sense of this list. Now we got to understand what this labeler function is. So he builds this function called labeler, and now we have to go back and review what our regex is. If you don't code every day, and if you're not a software engineer, you know, like me, I know I've done software engineering, but I don't do it every day. So whenever I see regex, I have to go back and review it because I don't remember all of it. And the easy way to do that is, so what he's doing here is he's got this function called regex labeler that gets so it gets applied to whatever to some input function. But let's pay attention to what this pattern is. It's this string. I mean, it's this regex statement, which is caret and then curly, sorry, round brackets, and then dot star underscore slash d. Anyway, what is all this? So you can kind of see this is a digit, slash d is a digit, and plus means one or more digits. It has to have an underscore before it. But then what's this pattern inside here? This thing is an anchor that says, look for this pattern at the beginning of the line. And what pattern are we looking for? We're looking for any character except a line break. Okay, and let's see. So so that's what the pattern we're looking for is. And how do you do this? Well, you go to some regex cheat sheet. That's what, when I need to look up something, first I don't even know where the cheat sheets are, so I Google regex cheat sheet, and then I find one. The one that comes at the top of the list is very nice. It's from MIT. And it's basically a dictionary of all the possible things, so you can remind yourself of what all these commands are. So first of all, you can see that slash d is a digit, any digit. The caret, let's see. Oh, the round brackets means you're capturing a group. So the group we're capturing in our command here is dot star, and dot star turns out to mean any character except the line break. So that's, and how did I find that out? Well, you look up what the dot is and you look up what the star is. So let's see. Let's see. This is the dot, any character except a line break, and let's see. Star means one or more. So the star means it's greedy. So it takes 0 or more. So there could be no characters, or there could be 1 or 2 or any number of characters. So it's looking for a bunch of characters before a underscore. And it's going to capture all those characters, and the output is going to be this captured group. All the characters that come before the underscore. Okay? So whenever you're faced with regex, don't give up. Just go to a regex cheat sheet. This is presuming you've seen it once, I guess. If not, you probably have to go through some kind of an introductory blog on what is a regex regular expression. But you know, I've seen it enough times so I kind of remember basically what things are, but I have to remind myself in detail. Some of you probably speak regex. You don't have to do that. You already know what it means. Let's see. Let's see. So this is where this is about. I think I got down a little bit close to here. So let's see. List of map labeler. So labeler now is a function that you can use to map items with, and so vals is this list that you get from applying this labeler function to a list of items. And then you build the vocabulary by uniquify. I guess that's a FastAI 2 function that, you know, given a list, it only looks, it gives you the unique values of that list, because a lot of times you have repetitions, right? So it's going to sort them. I'm not sure what this bidir command means.
The bidirectional, that's what helps you provide or not provide, that's what guides the uniquify function to also output the O to I, which is the reverse dictionary.
Okay, the reverse dictionary. Okay, so the vocabulary are the labels. The O to I is the mapping from the labels to the index of it. So here you can see it. If I hover over O to I, you see that it's a dictionary that maps the label string into an index. Okay, and the vocab is simply the list of all of the label strings. We've seen it already. Okay, so now we do this pet transform on. Okay, so it takes these three things as its input. We've already seen that that's what it's expecting as an input. It wants vocab, O to I, and the O to I dictionary, and the labeler function, and then it takes those in as methods. So now we've given it all the inputs that it needs, right here. And now we can see what happens when we apply it to an image. It has the right shape, and as you can see, it has the x and the y. So it puts out a tuple, right? And the first element of that tuple is the image, the tensor for the image, and the second element is the label. So now we can see what those two things look like. X dot shape.
And sorry to interject,
Sure.
but one point I wanted to make, in a sense, this is where the question, I think it was Dinesh who asked, what do you supply? And here's where, for example, the input to transform, therefore, what encodes uses as its input O is item 0, which is actually a path. So you do need to understand, yes, what Ellie said is true of the decodes, because you can see it's in a simple instance like this, it's just the output of the encodes. In more complex transforms, you have to watch the composition. But in simple case, that's true. The input, however, to encodes, you can see is item 0, which is actually a path. So you do need to be aware of what you need to pass to that in order to get what you want.
Srinivas,
Okay.
I have a question. So in this case, like pet transform, we have subclassed it from actually like transform. So I was expecting that to be operating on individual thing rather than a tuple. But this is where I get confused on where to actually like use transform versus where to subclass from item.
Yeah, and it is confusing even for me when I've gone through a few of these videos. I think it will become clearer as we proceed. I believe, and I could be wrong because, as I said, I'm still not 100% certain of this, but as we go through it, you'll find that transforms typically act on tuples, but that's not, when you don't provide a tuple, then that's not necessarily true, and you can make the transform act on items within the tuple. So it is a little bit confusing. You'll just have to wait until we dive into the details of the transforms and as he unveils it piece by piece.
Okay.
But typical rule, if I recall correctly, subject to anybody else correcting me as we go through it, is I believe transform by default operate on tuples.
Okay. So this is what Srinivas said, is that the input to this, the input to the pets, it has to be a path. So it's starting with the path, and then it's extracting out of that. That path is the path to the image, and it's able to extract both the image and the label because it knows how to extract labels. For this to work,
so it goes through the set code, the class code that you just showed a few cells back. It takes it and runs through the 3 steps. It labels it, then converts it to vocab and O2I, and then I forget what the 3rd step is, but and then passes it to pet transform.
Right, and so what comes out is the image and its label, the transformed image and its label, and we can see that the label is 21. So we can ask ourselves, what is that? Well, it's a Great Pyrenees dog. And so now when we ask it to show the image and its label, the show method, it knows to put the label on top. Okay, now this is as far as I got, and I think it's as far as I got. So it's 9:30 and we're done for the day, but there's a lot more in this. There's a lot more in this notebook, and so I just urge you to go through it the same way we did in class. And you can see that we're doing nothing more than just asking ourselves questions about what's going on in each cell and trying to follow the rabbit hole if we want to, or just making ourselves a note that we probably need to understand this for later. And with the combination of those two methods, you'll get through this. And so the Slack discussion group is for questions. If you have questions on any of this stuff, ask it, and we'll all pitch in and try to answer. And also, I remind you that there's a resource on in the FastAI forum where where they have notes for each one of these videos. So that will help. And of course, the first resource is what Srinivas has produced for us, which is a PDF file that tells us. I forgot about this, Srinivas, and so I've worked it up for myself. But Srinivas made a file that is helping us to figure out what we need to do about each of these videos, what's different than the original video, which notebooks we should be looking at for this video, and so on. So make use of that resource too.
And I'll post it for the next one just after. I just wanted to wait. Joseph, it may be worthwhile because there are some key concepts like pipeline setup and stuff. So my thinking, my recommendation would be, at the risk of pushing this out, is to start here and go through the rest of the notebook next time as well, because there are some very fundamental concepts that if people haven't gone through or just click through without discussion, that it wouldn't lead to a good understanding, like setting up, what does setup do, what are TFMD lists and data sets, which is all covered in the rest of this notebook. So my 2 cents, and feel free to override if you think not worth it, but it's good to start here and go through the rest of the notebook in the next session of this class.
Okay, I'll take your recommendation at face value. That's what we'll do. I don't want to rush through these things. In my experience, if you try to stick to a schedule and rush through everything, even though we see that there was way more material we can cover, we're just going to all get lost. So let's do that. It doesn't have to be. I'm not stuck to this schedule of 10 weeks. I mean, we can take however long we need to get through this stuff. And I hope everybody's agreeable with that. So next time we'll start where we left off, and we'll cover the second half of this video.
Yeah, I think that would be really good. And my 2 cents again, because I went through, in order to generate my slides for today, I went through the whole second, and it's even bigger and probably will at least take 2 sessions to get through the next one.
That's
so
fine.
You may want to put that up split it into 2. In fact, there are 3 parts to it because it refers to this. It completes this notebook, then goes through another notebook, and then a third notebook piece in the second lecture. So I'll post that right after we are done, but I would still say let's take the next session to go through the remaining part of this notebook, which will in fact take us a little bit into lecture 2 as well. And then that lecture 2 or video walkthrough 2 will take probably, in my estimation, a couple of sessions to go through. And
okay, Srinivas, I really appreciate your guidance on this, and I think we'll follow that. I want to. My goal here is not just to get through this material, but it's to understand it. So we'll take however long it takes to, and maybe it'll take 2 sessions per video, or maybe some of them will take 3. That's fine. We'll just extend the schedule to accommodate.
Thanks, Joseph. Yeah, I think it will be worthwhile.
Okay, everybody. We'll end this here, and we'll see you next week. Starting